So we're going to talk about the bitwise and the bitwise OR. Doesn't even show what the bitwise OR operator is, but it's a vertical bar. A vertical bar means bitwise OR. Just like 2 bars means OR, 1 bar means bitwise OR. So that means and. That means OR. A single and means a bitwise and a single bar means a bitwise OR. So what does bitwise mean? Well, we talked about, like, if you have the number 7 in binary, that's equal to that. A 1 plus a 2 plus a 4 with no 8s. And if we made it an even byte and padded it out to 8 bits long, it would look like that. That's a 7. And what if we add another number here? That was, I don't know, 21. And I don't remember what 21 is, so I'm going to cheat and say 21 in binary. It's equal to that, 10101. Alrighty. So 10101 with 3 zeros at the beginning of it. Okay. So if we do this, 7 and 21. If we said x is equal to 7 and 21. Well, we've already established that and means both, right? And means both have to be lit up. Well, it checks to see which of these bits, which columns are both set. So if I do that, and I AND them together, then 1 and 1, well, that one's set. 1 and 0, well, only one of them is set, not both of them. So that one didn't work. How about that one? Are they both set in that one? Yep. All right. And then none of the rest of them have them both set. And so that's the answer. 101, which if we add it together, that's a 1. There's no 2s. And a 4. So there's a 1 and a 4. So that's equal to, counterintuitively, 5. That's what bitwise AND means. Let's do one more. Let's say that we had the number 96. I'm going to pull that up, type it in here, 96 in binary. It's 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. That's what 96 is. And I'm just going to totally make up another number and then figure out what it actually is. Alright, so there's no 1s, but there's a 2. There's no 4s, but there's an 8, so that's 10. No 32, but there's a 64. 10 plus 64 is 74. You know what? Brain. So there's a 128 plus a 2, 8, 32, 128. We remember how to do that, right? There's no 1s, but there's a 2. There's no 4s, but there's an 8. There's no 16s, but there's a 32. There's no 64, but there's a 128. So if I take that and I add that together up in Google, then I'll get a number, 170. Alrighty. So I have this number 170 here. But instead of doing it bitwise and, well, I could, but there's only one place where they're both set. And which place is that? 3 over, right? And if we count them over, what place value is that? 1, 2, 4, 8, 16, 32. So the 32 bit is set. So if we did, I'm going to delete this. If we did 96 and 170, that's equal to 32, because that's our answer when we AND them together. What if we ORed them together? Well, we have a 1 and a 0. Is that a 1 or is one of them set? Yes, one of them is set in this column. How about the next one? Is one of them set in this column? Yep. Is this making sense, Kenya? We got a 1 and a 1 here, so at least one of them is set. We're doing an OR here. Do we have any 1s in this column? You tell me. Do we have any 1s in that column? There's a 0 in the 4th column there, and there's a 0 in the 4th column there, so there's nothing there. So that's a 0. Do we have any 1s in this column? Nod your head yes or shake your head no. You're looking like you're in a panic. Okay, but all we're doing here is, since we're doing OR, we've already talked about OR meaning either or, if one or the other is set. And by set, I mean if it's non-zero. So we're just going from right to left or left to right, seeing if the places are set or not. And so OR means both of them have to be set. No, OR means only one of them have to be set. Just like if I am sick or tired, I can go home. Only one of them has to be set for me to stay home, right? So if I was tired, if I was not tired but I was sick, I get to stay home. If I was not sick but I'm tired because I have a generous boss, I get to stay home. If both are set, even better. I can just, if I'm sick and tired both, then I stay home. But if they're both false, if I am not sick and I'm not tired, I have to go to work. So that is expressed like this. If we have a false and a false, and we OR them together, if either one of them is a true, then the result is true. But if neither one of them is true, then we get a false. And so in this case, a false or a false is a false. Neither one of them is true. I wasn't sick and I wasn't tired, so I couldn't stay home from work. False. What if I am not sick, but I am tired? Well, my boss is generous. Since it's an OR situation, only one of them has to be true. And so that's a true. I get to stay home. Or if I'm sick but not tired, weird state to be in. But again, since we're talking about OR, one or the other has to be true for the result to be true. And since I'm sick, even though I'm not tired, I'm going to stay home. And if I am sick and I am tired, well, so much the better. They're both set. So when you do this, we're treating these zeros as though they are false, and these ones as though they were true. And so we're just lining them up. That's an OR symbol. And so, sorry guys who are watching this at home, you're not getting to see me right on the board. I hope it kind of makes sense what you're hearing. Going from left to right or right to left, it doesn't matter as long as we just line them up. Because if we were adding them, right, if we were adding them, we'd know how to add them. We'd say a 0, we'd go over here, you know, and say, okay, a 0 plus a 0 is a 0, and a 0 plus a 1 is a 1, and a 0 plus a 0 is a, right? We know how to add them. We know that they line up like that. But instead, we're doing the OR. We're doing the vertical bar. So we're just checking to see whether we have either one of them set. But I don't have a 0 there, I don't have a 1 there or a 1 there. So that winds up being a 0. How about the next column? Are either one of them a 1 in the next column? Yeah. Yep. The next one, nope. Neither one of those are 1, so that's false, that's a 0. And that's a 0 and a 1, so yep, we have 1 in that column. And then a 0 or 0, nope, nothing's set up there. A 1 and a 1, yep, we have something there. And a 1 and a 0, yep, got something there. And a 0 or 1, yep, got something there. So that's what these two things, bitwise just means we're comparing the bits of them together, come out to be. So now for the benefit of the people at home, I'm going to do the same thing. We were started on it. Either a 0 or 1 makes a 1 or a 0 makes a 1 or a 1 makes a 1. Here, neither one of them are set, so the result is a 0. Here, at least one of them is set, so that's a 1. Here, none of them are set, so that's a 0. Here, a 0 and a 1. Well, we got 1 set. So that's a 1, and here we don't have any set. So that's a 0. That's the way OR works. That's bitwise OR. One of the two must be true, but not both. And means both of them have to be true. Like, for me to go out to eat, I have to be both hungry and have money. So if I'm hungry and I have money, then I go get a Snickers. Otherwise, I can't. I'm not going to get a Snickers if I'm not hungry. I'm not going to get a... if I don't have any money. So that's a logical AND. A logical AND means that both sides have to be true before the result to be true. Since it's an AND, which is represented by the ampersands. So, since both sides have to be true, I could set it up like this. Hungry and money equals Snickers. False and false. If I don't have any money and I don't have any Snickers. Excuse me. If I'm not hungry and no money, then I don't get the candy. If I'm not hungry, but I do have money, well, there was no reason to get it. I'm hungry, but unfortunately, I don't have any money. Here's the golden point. True and true, I am hungry and I have money, so the result is true. So for OR, only one side has to be true for the result to be true. Either A or B. And if they're both true, so much the better. For AND, both sides have to be true. Trying to think of other examples. So, if cold and leaving the house, wear a coat. So cold and leave house and coat. So false and false. It's not cold and I'm not leaving the house. So am I going to wear a coat? Nah. Alright. It's not cold, but I am going outside. Leave house is true, but it's not cold, so I'm not going to bother wearing a coat. It is cold, but I'm staying home. It's cold and I'm leaving the house, and so now I'm going to get my coat. So AND means both of them have to be set. So if you do something like this, if age is greater than 17 and citizen, years that you're a citizen, is greater than 0, then voting is equal to true. Then you get to vote. Now I'm going to change these into the symbols that they are. So I'm going to change that so like that. So I have to be both 18 or over, and I have to be a citizen before I get to vote. So depending upon what my variables are, if I set age equal to 16 and citizen equal to, I've lived in the United States all my life, but my age is only 16, then age is not greater than 17. So that's false. And since ampersand means AND, which means both sides have to be true, it's not going to print you get to vote. How's about if we change these values, though? What if we said my age was 26 and I've been a citizen for 6 years? I get to vote because 26 is greater than 17 and years of citizenship is greater than 0. So I do get to vote. I could be 106, but if I haven't been a citizen, I don't get to vote because this is not true. 0 is not greater than 0. So it doesn't matter that I'm older than 17. I still don't get to vote. So that state would set up a situation where it doesn't print that. So let's fire Visual Studio and set up a few like that. I think this is lecture H. C_lecture H. So lecture H.C. Grab my boilerplate. Wrong. Oh, it looks like I have my warning back there. Okay, well anyways, I'll get rid of that. Don't want that one there. Okay, so if we Google up when you can enroll in the Coast Guard, what ages you have to be in the Coast Guard. Age to enlist in Coast Guard. What we'll find out is that if you're between the ages of 17 and 31, then you can enroll. But if you're 17, you need parental consent. That's if you want to be in active duty. If you want to be a reservist, you can be 17 through 40. Okay, so we're just going to say between 17 and 31, you can be a member, but you have to have parental consent if you're under the age of 18. So we're going to set up two variables. Int age, why not just initialize it to 0? And int consent. And we could use scanf to ask for each things. So let's print f. What is your age? Question mark. Space, space, greater than, end quote, semicolon, or parentheses, semicolon. And now we're going to use scanf to read into it. Scanf, parentheses, quote, it's an int, integer, so integers require %d. End quote, comma, ampersand age. Now, if our age is between those two values, if it's 18 to 31, we can enroll without parental consent. So let's do that. If age is greater than equal to 17 and age is less than equal to 31, both of those have to be true, then we're going to print a message. Printf, parentheses, quote, congrats. You can enlist in the Coast Guard. I can't spell, but we can do it. We can enlist in the Coast Guard. But we might not be. fall within that category. So if our age is 17 exactly, we need to clarify whether we can enlist or not. So, else, if parentheses age is equal to 17 exactly, then we better ask for permission. That if should have been on the same line as else. So else if age equals 17, let's find out. Let's ask them for consent. Printf, parentheses, quote, do you have parental consent, question mark. 1 equals yes, 0 equals no. Space, space, greater than, end quote, end parentheses, semicolon. So now we're going to use another scanf to read into that second integer variable we declared called consent. So scanf, it's still an integer, so quote %d, end quote, comma, ampersand consent. And now that we have those two pieces of information, we can see if they can enlist. Now, but really we only need to check that. We don't even need to check age. We know what our age is at this point, so we don't need to do this. If I typed if age equals 17 and, right, I don't need to check the age because we've already checked the age up here. So I don't think this one's going to even have any ands or ors in it. So let's just do, oh, but let's set it up that way anyways, even though it doesn't make any sense, just because it looks good. If age equals 17, ampersand, ampersand, meaning and, consent equals 1. Now I wish I'd set this up a little bit differently. Well, I guess too bad. I'm not going to go back and change too much of it. Well, if that's all true, then let's just print out our message again. So I'm going to copy it and print that. I definitely wish I'd structured this a little bit better. And if you don't mind, I'd like to go ahead and do that. So what we're going to do is up here, I'm just going to kind of push all this stuff down for the moment because we're going to make a change right here. The only time we need to ask for age is if we're consent is if we're at 17. So if parentheses age equals 17 in parentheses, move this business right here, those two lines, right up there. Whoops. And then just close that with a curly brace. Okay, now this doesn't have to change any. That thing about if age is greater than 17 and age is less than equal to 31, that's okay. But we got a little bit to do here. So here's what our code looks like right now. If our age is 17, we ask them for the parental consent form. Then we come down here. If your age is greater than 17 and your age is less than or equal to 31, then you can enlist in a Coast Guard. Else, parentheses, if age equals 17, ampersand, ampersand, consent equals 1, curly brace, and let's print the same message. And I'm sorry, that parentheses is in the wrong place. Like that. So else if age equals 17 and consent equals 1, then we're going to print our message again. Congrats, you can enlist in a Coast Guard. But otherwise, bummer, we don't get to. Our lifelong dreams are dashed. So printf, parentheses, quote, sorry, ineligible for Coast Guard service, period, \n, end quote, like that. And just to make it all fit on the screen, I'm going to take some of these curly braces out. just so I can get more of the code on the screen at the same time. Can't quite get it all. Maybe if I get rid of this. But I can get close. As long as you know that above here we have these two lines, int age is equal to 0, int consent is equal to 0. That's the top of our program. And then the rest of it does fit on one page. Well, I better test it out. I've talked a good game. Let's see if it works. All right, what's your age? Well, I'm 90. Sorry, I'm ineligible. All right, no surprise. What's your age? 30. I am eligible. Now let's see what happens if I'm too young, like I'm 16. Sorry, you're ineligible. What if I'm 17? That's a special case. Do you have parental consent? 1 equals yes, 2 is equal to no. First time I'm going to test it out, I'm going to try no. And it goofed. Congrats, you can enlist in the Coast Guard, even though I typed no. I wasn't expecting that. Totally was not expecting that. I guess I'm going to print out the consent after I type it in. Did this happen to us last time where we ran into something where we typed it in and we didn't? Anyways, printf, parentheses, quote, result, colon, I'm just adding this. You don't need to add this when I'm trying to figure this out. Consent equals %d \n, end quote, comma, consent in parentheses, semicolon. I want to see what the value of that variable is. And if that doesn't work, I'm going to enter the interactive debugger, which is a good thing to show even though I haven't done it yet. Okay, I'm 17. Do I have parental consent? No. For some reason, it's saying I can enlist in a Coast Guard. So I don't know why it's saying that. So I'm going to do what's known as setting a breakpoint. You see this kind of gray column out over here? I can click on it, and I can tell it that while it's debugging, I want it to stop at that point. So as soon as I've typed in my age, I want it to stop there so that we can keep watching the logic. Now I'm going to run it inside the local Windows debugger. And so it's asking me for my age. 17 seems to be the trouble spot. All right, and now it's stopped there. And there's a little arrow telling me that that's the line number that I'm on. I can hover my cursor over the age variable and it'll tell me that age is 17. So now I'm going to skip to the next line. There's a step over symbol. There it is, step over. And so when I step over, it's going to go to the next line. Well, if this wasn't true, the next line would be down here. But this is true, so this should be the next line that it executes. Let's find out. Step over. Okay, it went there. Step over again. All right, it's about to execute the scanf. If I click step over again, it sits there and waits for me to type. Do I have parental consent? Yes or no? 0 for no. Now I come back here and it's ready to print it out. This is the current line. So as soon as I step over again, it's going to print that out. If I hover my cursor over the variable, it shows me that consent is still equal to 0. So step over. All right. Is age greater than 17 and age? Oh, that's my problem. I made it say you can enlist. Tell me if you spot the error with that if right there. According to my rules, that said that if you're 17, you have to have consent. It's at the age of 18 that I can get in without consent. So I botched that. That's why I was getting the wrong answer. So I need to change that to an 18. Then it'll run. I can even get rid of that breakpoint. I'm going to do that. I'm going to come over here and click the red circle again to get rid of it. Then I'm going to run it. Okay, my age is 17. I don't have parental consent. Sorry, ineligible. Now I can get rid of that stupid print statement I had there. I just added that for debugging purposes. I didn't Don't need it now. All right. So I believe it works, but I haven't tested the final case, which is when I'm exactly 17, and I do have parental consent. Yep, okay, so we are good to go there. I want to make sure that y'all have it going too. So that's an example of and, right? If we're greater than or equal to 18 and our age is less than or equal to 31, that's how you check within a range. To check within a range, you use and. To check outside of a range, you use or. What do I mean by that? Like, water is a liquid, or it's an ice, or it's a gas, it's boiling. It's a liquid that between the temperatures of 32 and 212. So we're going to check, ask them for the temperature of the water, and then we're going to tell them whether it's a liquid or not. So I'm going to add that as a comment. Water is a liquid between the range 32 to 212. Above that, it is boiling. Below that, it is freezing. So let's ask them for the temperature. I guess we should declare a variable first. W temp for water temp. So printf, parentheses, quote, what is the current water temperature? Temperature, question mark, space, space, greater than, end quote, end parentheses, semicolon. And let's read it in. Scanf, parentheses, quote, %d, end quote, comma, ampersand wtemp, W-T-E-M-P. So we're going to check. First, let's check to see if it's within the range. We're going to find out if it's liquid. Is it liquid? So if, parentheses, W temp is greater than, equal to 32, ampersand, ampersand, W temp less than, equal to 212, curly brace, printf, the water is liquid, period, backslash n, end quote, in parentheses, semicolon. If we wanted to check to see if it's out of range, we wouldn't use and. We'd use or, something like this. If, parentheses, W temp less than 32, or, shift vertical bar, bar, or W temp is greater than 212, close parentheses, printf, parentheses, quote, the water is not liquid, period, backslash n, in parentheses, semicolon. So let's find out what it is. Let's find out if it's boiling or not at that point. So at this point, we're just going to check to see if it's greater than 12. So if parentheses W temp greater than 212, in parentheses, I should just copy and paste one of these printf statements and go faster. I'm going to copy that printf and then change it. Printf, the water is boiling. Else, printf, the water is ice. And so let's try it out. Let's run it, 4 or 5 times. First with a temperature you know, 78 degrees, whatever. Try it at 32, which should still be liquid. It's pretty darn cold though. And then at 31, where it should be ice. And 212, where it should still be liquid, although it's pretty hot. And then 213, where it should be steam. What's your age? I don't know. It's 1. What's the current water temperature? I need my font larger. Okay. 78. It is liquid. All right. Let's try it again. What's your age? I don't know. 1. What's the current water temperature? 30. 30. It should tell me that it's ice. It's not liquid, it's ice. Run it again. Current water temperature, 300 degrees. It's not liquid, it's boiling. Now we could have set the logic up a little bit different, but I wanted you to see this. This is checking to see if it's within a range using and this is checking to see if it's outside of a range using or. So I guess I'll add some comments to that effect. We used and to check within the range. And here I'm going to add a comment saying we used or to check outside of the range. And there are other ways to set it up. We could have just checked 3 different times. If, else, but that wouldn't have demonstrated checking within a range and outside of a range. We could have just said if temperature less than 32, print ice. Else if temperature greater than 212, print boiling. Else print liquid. That would just look like this. But it's going to be too many print statements. I'm going to leave that alone. I'm not going to bother. Does that make sense? Is it running for you? Okay. Okay, cool. So those bitwise ands and bitwise ors, what do people use those for? Well, say you want only the last 4 bits of a number. You have some number, any number. Doesn't matter what it is, like that. And you only want the last 4 digits. Well, if that's true, then you AND that against some number where only the last 4 digits are set. So I'm just going to ignore all of these zeros. I'm going to delete them. That's a 1. That's a 2. That's a 4. That's an 8. So this is 15 here. So if we AND any number with the value 15, we're going to get only the last 4 bits. So we could do that. We could do something like that, or we could ask for this value, and then we AND it against 15, and we'd find out what the last 4 bits are. Well, let's do that. If you just want a single bit, then you could AND this number against like something like this, right? That would tell us what the last bit is. This would tell us what the second to last bit is. That would tell me what the third to the last bit is if I AND it against it. And that would tell me what that bit is. So let's ask for some input and then find out what the last 4 bits are. So I guess I'm just going to call it value. I'm not coming up with a brilliant name. Int value equals 0. Printf. Check the last 4 bits of what number, question mark, space, space, greater than, end quote, close parentheses, semicolon, and then a scanf. Scanf, parentheses, quote, %d, end quote, comma, what do I do here? What comes after my comma in my scanf statement?
Ampersand.
Yep, ampersand value, not vaki, value, close parentheses, semicolon. And so, I guess we could just declare 4 bits and call them bit 1, bit 2, bit 3, bit 4, something like that. Int b1 comma, or let's call them b4 comma, b3 comma, it doesn't matter their names, b2 comma, b1. And we're going to say that bit b1 is equal to value ampersand, and I want to check just for this bit. And so if this is the only number that's lit up, then that's a 1. How about this one? The 2's place is lit up, right? There's no 1's, but there's a 2. How about that one? What place is lit up in this variable? If that's the 4th place, 1, 2, 4, and 8. And then, so if that's 1, and that's 2, and that's 4, then this will be 8. So, B1 is, I'm checking for, I'm totally confusing myself. I'm going, well, you're confusing me too. Alright, so let's check against that, against 1. So, value, ampersand, 1. B2 equals value, ampersand, 2. Not V2, B2. Sorry to change gears, but since the place values are 1, 2, 4, and 8, why don't we make our variables match? Let's make them say 8, 4, 2, 1. 8, 4, 2, 1. So B4 equals value ampersand 4, and B8 equals value ampersand 8. And then we can print them out. It's just going to be printf with 4% D's in it. And if those things are set equal to 1, then it's going to print out a 1. And if they're set to 0, it's going to print 0. So, printf, parentheses, quote, here are the last 4 bits, colon, space, end quote. Now, I'm not going to put a new line because I want these bits to show up on the same line. So I'm not putting a slash in there. But of course I am going to put an end quote in parentheses semicolon. And now let's do printf parentheses quote. We need 4 place values, placeholders for those 4 bits. %d, 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 %d. Or we can space them out. It doesn't matter. \n, so it will go to the next line. End quote. And we're going to print out B8, B4, B2, and B1. B8, B4, B2, and B1. Age, 5. Water temperature, 5. Check the last 4 bits of one number. What number? Now I happen to know that 127 has the last 4 bits set to 1. I just happen to know that. So I'm typing that in just to test it out. Ew. Alrighty then. It did not do exactly what I was expecting it to do at all, and I'm not sure where to take this example. It's correct. But it didn't go where I wanted it to do. And I'll tell you why. That's because the result of it is not That's because if you took this number and if you ANDed it with this, let's figure out what it's going to give us. So I'm going to take these 2 numbers right here. I'm going to ampersand them against each other. And what's the result going to be? It's going to be all zeros except for that one, because we have 2 1s here. So it's legal for that one to be set. And then what is that equal to? That's equal to 2, right? 1, 2, 4, 8, 16, 32. So 0010 is equal to a 2. I did cover that on Monday, right? Yeah, I did do the bits and okay. So we did get these values. We got the 1, 2, 4, and 8. We just didn't get them in a nice, pretty, easy way to print. Well, we could add 4 more variables. Int I8, comma, I4, comma, I2, comma, I1. This is going to look stupid, and I almost hate to inflict it upon you. I8 equals parentheses B8 equals 8 in parentheses in semicolon. And I'm going to do the same for I4, I2, and I1. I4 equals B4 equals 4, close parentheses, semicolon. I2 equals B2 equals 2, in parentheses, semicolon. And I'll explain what it's doing in a minute. And it's kind of okay if you don't totally get it. All right, and then I'm going to change these to I8421 rather than B8421. Okay, so what is this showing us? What does that mean? The thing inside the parentheses happens first. And so it checks. You know, we got a bit out of it using the bitwise AND, and now we're going to see if the right bit was set. And if it is, then this is true. And a true gets copied into I8. Well, a true is just a 1. And then the next one, where we ampersanded with 4, we check to see if it's equal to 4. If it was set, then it is equal to 4, and so that'll be true, and we'll copy a 1 into it. But if it's not set, if that bit was 0 from up here, then it's not going to equal 4, and so that's going to be set to false, and a 0 will be copied into it. Age 1. Current water temperature 1. Last 4 bits of what? If I type in 15, I should see 1111. And we do. Why is that equal to 15? Because that's a 1 plus a 2 plus a 4 plus an 8. What about a different number? What if we wanted to see a number that looked like that? What number would that be? If that's the 1's place, and that's the 2's place, and that's the 4's place, and that's the 8's place, what does this add up to? Do we have any 8's?
6.
Right, it's a 6 because we don't have any 8's, but we do have a 4, and we do have a 2. So when I run it again and I type in 6, I should get 0110. I accidentally put a breakpoint in there. My program's going to stop. 1, 1, 6. Yeah, come back over here. And then it did it. 0110. I hope you kind of have the idea of the bitwise AND and the bitwise OR. If what we did here doesn't totally make sense, that's okay. I kind of would like for you to have the idea of checking to see if something is true and false and storing a result in a variable as a result. That would be something like this. I don't even know what variable I'm going to call this. Int num. I'm going to set it equal to 32 or something like that. And then I'm going to do some other variable. Is equal to parentheses num greater than 100 in parentheses colon. Now if I printf that, well, is num greater than 100? Is this part a true? Is everything inside the parentheses a true or a false? Well, num is 32. Is 32 greater than 100?
No, it's false.
Right. Num is not greater than 100, so it's a false, and so a 0 is going to get copied into B. So if we print it out, printf parentheses quote B equals %D \n end quote comma B, it's just going to print 0. What is your age? 1, 1, 1. Okay, but what if we change this to like less than? Is 32 less than 100?
It's true.
That is true. So instead of a 0 getting copied into B, a true is going to get copied into B, which is a 1. So the last thing is going to be a print 1. And B is equal to 1. How's it running on here?
Okay.
Let's put a semicolon there. After that unit value, semicolon there. Let's see these two lines and let's close our quotes. All three of those lines and paste it at the very bottom. Because that's the very end of the program, it's like that. We've talked about bitwise and we've talked about logical. There's this thing, the conditional operator. I'm going to go ahead and show you what that one does. Hopefully it's not as weird as the stuff we've been looking at. So scroll all the way down here before your system pause. And first I'm going to type it into Notepad so that you're not typing along with me. What if we had something like this? What if we wanted a variable that was set to 1 if a number was positive, and it was set to -1 if the number was not positive? Or if it was just set to 0 if it was not positive, and if it was set to 1 if it was positive. So that's what I'm going to try to write. Write code that will set a variable named p if value is positive, meaning greater than 1. It will set it to 1, else it will set it to 0. We could write that like this. We could ask for the value, but who cares? Int value equals 9, whatever, as long as it's greater than 0. And then int p, this is our special variable that we're trying to set. We're trying to set it to 1 if it's positive. So if value greater than 0 is positive, we're going to set p equal to 1. Else, we're going to set p equal to 0 because it's not positive. So we had 4 lines of code here. There's nothing wrong with doing it in 4 lines of code. But the folks who invented C wanted to make a nice, sneaky, short way of doing it. In which case it would look like this. Same start, int value is equal to 9, int p, and then p is equal to, and here's the way we read it. We put something in parentheses, which is the same as this. If value greater than 0, in parentheses, question mark, like we're asking a question. Yo, is the value greater than 0? If it is, we want to copy a 1 into p. And then I put a colon there to indicate that if it's not true, I want a 0 to be copied into p. And then if I printed p, it would be 1 if it was greater than 0, else it would print a 0 because it was not. So these two chunks of code are the exact same thing. They look different, but that's because this one statement replaces these 4 statements. This is called a conditional operator. What it means is check this condition, and if this condition is true, do the first thing after the question mark, else do the second thing after the question mark. And you can word it other ways as well. Let's come up back into here. And we had some age variable that we typed into the very, very beginning of this. Let's just do age greater than 65. In parentheses, question mark. Is age greater than 65? If so, printf time to retire, \n, end quote, end parentheses, colon, printf, parentheses, quote, no retiring yet, \n, end quote, end semicolon. Now that line became too long to fit on my screen comfortably, so I'm going to have to zoom out for a moment. So that's what the question mark means. It means, is the thing before true? Then do the first thing. Else do the second thing. Now I would personally never code it like this. The only reason I'm demonstrating it is because it's shown in the book. The question mark is shown in the book, so we have to cover it. So if my age is 99, then eventually it should say that I'm time to retire. Now I'm going to run it again with my age being less than 65. I'm 64 years old. No retiring yet. So the question mark is the conditional operator. The question mark is the conditional operator. The part before the question mark is evaluated. If it is true, the part after the question mark happens. Else, the part after the colon happens. So this part is evaluated. If that's true, it does this, does the thing after the question mark. But if it's not true, it does this part. And these parentheses here, I just put there to make it easier to read. It would work just as well if we did that. It just kind of looks weird to me. Well, all of it looks weird to me, but I'm going to leave it like that. And one more example. Char star ch equals age greater than 65 question mark quote, or yeah, question mark quote, retire, end quote, colon, keep working, end quote, semicolon. And now if we print out ch, printf parentheses, quote, here is, now let's just print it out, %s, since it's a string, \n, end quote, comma, ch, depending upon whether what we typed in earlier is greater than 65 or not, it's going to print out either retiring or keep working. And it's about time to stop. So my age is 1. It's not going to print that I'm going to retire. No retiring yet. Keep working. So that's what the question mark means. Check the thing in front of the question mark. If it's true, the whole thing is equal to the first part. Else, the whole thing is equal to the second part. And since I did not type in an age that was greater than 65, then our variable was not equal to retiring. It was equal to keep working. So that's the conditional operator. Alright, so we know what an if is. If something, then do this. And this is demonstrating using the ampersand. Why don't we stop here? Here's what our homework's going to be. I'm just going to steal it from another class. So Just a moment while I go fetch it. So if, else, and or. What are we going to do? We're going to ask them for their age, and we're going to ask them for the years of employment. If the age is greater than 17, and if the years of employment is greater than 2, sorry about this bad spacing. I don't know why it's spaced like that. I better copy and paste it into another file. Then print, you get free checking. If the age is less than 17, or their years of employment equals 0, then print, enroll in the training program. So that's the first part of it. We're going to play with their age and their years of employment and make 2 decisions based on that. Then after that, ask the user how many calls he has made and how many minutes he has talked. If the calls is greater than 100 or minutes is greater than 1,000, then we print upgrade to the higher plan. If the calls is less than or equal to 100 and the minutes is less than or equal to 1,000, print stick with the current plan. And lastly, if the calls equals 0, print you may as well cancel your plan. They didn't make any calls this month. Now my company would jack me up and want me to pay more if I hadn't made any calls, but that's okay. So I'll reformat this and make this a nicer, prettier homework assignment. But I think we have lectured enough. So I'll make a Dropbox so we can upload stuff and we will be done.